Socratic Math Tutor here. So today we're going to learn to find the square roots of large numbers, such as, for example, 30276. If you don't have a good technique for this, this probably looks quite hard. And honestly, this technique is a little bit tricky. I'm not going to sit here and exaggerate how easy it is, but it's also quite doable if you take the time to learn it and to practice it. Okay, so to get started, we need to pair up digits starting on the right-hand side and proceeding left. So we'll pair up the 7 and the 6, the 0 and the 2. And as for this lone ranger out the front, it's totally fine for that to be in its own bucket. And indeed, anytime you have an odd number of digits, you're going to find that you do have this lone ranger here. So to proceed, we start on the left. We find the square root of this. The square root of 3 is 1 remainder 2. Now, this is not the answer your calculator will give for the square root of 3. That's totally fine. The reality is there's just not enough nice looking symbols out there to give each symbol in mathematics its own unique meaning. So in practice, what we do is we overload notation, and similar concepts will often get the same notation. And this actually works a little bit better than you might expect, because based on the context, you'll usually be able to puzzle out the meaning of the symbols used, and therefore you'll be able to understand the mathematics. So in particular, our meaning is that, okay, 3 is a perfect square plus a remainder. And so therefore, the square root of 3 is 1 remainder 2. You can do this really for any number. So for example, let's look at 13. So 13 is 3 squared plus a remainder of 4. Therefore, the square root of 13 equals 3 remainder 4. Yeah, so slightly different meaning to square root than usual, but that's totally fine. This is actually what we need to make the technique work. Let's get rid of that. And now we move on to the next pair. So what we're going to do is we're going to find the square root of 02, and we need to keep in mind that the remainder from the previous line actually needs to be brought into the next line. So we just stick that here, just bringing this number down and putting it in the leftmost place. The other thing is we don't actually want the square root of this. What we're looking for is a kind of modified square root. So to indicate that, I'm going to put an extra line here, and I need to put a number here. And the way you find this number, okay, you take your current answer so far. So this is our answer that we've got at the moment. We need to double this, so we get 2. And then we append a 0 to the right-hand side, obtaining 20. So I'm going to put a 20 here. And that's just coming from this digit by doubling it and then multiplying by 10. Okay, so now we've got to work this out. Of course, we can't work this out until I tell you what this notation means. So let's talk about the concept of this line and this extra number and what these are doing for us. Let's start off by imagining we're trying to find the ordinary square root of 202 with remainder. We'd probably say something like this. Okay, 10 times 10 is 100. This is too small. Let's try 15 times 15. We ponder it for a moment. We come up with the number 225. This is a little too large. Let's try 14 times 14. This turns out to be 196. This is slightly smaller than 202. And the next perfect square, namely 225, skips over 202. And so it follows that the square root of 202 equals 14 remainder 202 minus 196, which is 8. Okay, let's just pause there for a moment. Obviously, that should read 14 remainder 6, not remainder 8. It was just a miscalculation I made while creating the video. However, because this particular number turns out not to really matter, we're not going to re-record, we're just going to go on. So that's how ordinary square roots work. And this modified square root, it works in a similar way, but instead of our two numbers being the same, they're actually going to differ by 20. So for example, instead of starting off with 10 times 10, we can start off with 30 times 10. This is allowed because these numbers differ by exactly 20, which is the number we've got here. And this is 300, which is bigger than the number we're targeting, namely 202. So obviously we have to go smaller. So we might try, I don't know, 25 times 5. These still differ by 20, so this is okay. This turns out to be 125, which is quite a bit smaller than 202. So obviously somewhere between 5 and 10 is going to be our answer. So maybe next we try, I don't know, 27 times 7. You can work this out by whatever means you want. Personally, when you're first learning this technique, I recommend having a calculator next to you so that you can work these out quickly and not get bogged down in the minutiae of the technique. Obviously, in the long run, you are going to have to do these by hand, but if you're just getting started, I do recommend having a calculator handy. In any event, this is 189. And that's as close to 202 as we can get without jumping over. The reason is because the next number up is 28 times 8, and that's going to be this plus 28 plus a little bit more. And just adding that 28 obviously exceeds this number, and so at that point we've gone too far. So the key number here is really 189. So I'll just get rid of the previous line. And what we want to do is we want to write the square root of 202 with respect to 20 equals this number, so 7, with the remainder of, and to work out this remainder, we just do 202 minus 189, and that turns out to be 13. So this expression is 7 remainder 13. So before proceeding to the next part, we'll just clean up the whiteboard. Okay, so now we look at this pair of numbers, namely 76. We put that here. We need to bring this remainder down and put it on the left. So we're trying to find the square root of 1376. And it's one of these relative square roots, so we need this line and we need to put a number here. Our answer so far is 17. And so what we've got to do is we take this, we double it, getting 34, and then we multiply by 10, obtaining 340. So therefore 340 goes here. So let's just compare that with what we did earlier. So previously we took this number, we doubled it, obtaining 2, and then multiplied by 10, and that went here. This time we're taking these 2 digits, thinking of that as 17, then we double that, getting 34, and so therefore 340 goes here. So hopefully it's pretty clear how that works. If not, leave a comment below. In any event, we now need to work this out. Now, a nice little trick is to just kind of chop off digits until it's easy to divide what's left here with what's left here. So for example, 13 divided by 3 is 4 remainder 1. And that 4 is giving us a hint in regards to where to start in order to actually work this out, right? So we're going to start off by computing 344 times 4. Notice that these differ by 340. That's great. That's exactly what we want. Once again, you can work this out by whatever means you like. The answer turns out to be 1,376. And therefore, we learned that the square root of 1376 with respect to a gap size of 340, this equals 4 with the remainder of 0. So equals 4 remainder 0. And so at this point, we're done. Our answer is here. It's 174. Square root of 30,276 is 174. And this is an exact equality. It's not an approximation. That's because we got a remainder of 0 on our last line. Okay, so obviously if we had gotten 4 remainder 1 here, we would need R1 here. And in that case, the decimal expansion of this square root would be 174 plus a little bit more to account for this remainder. But we don't need that in this case. So I'm not going to sit here and say that was super easy. I mean, there were quite a few steps there, lots of opportunities to make mistakes, lots of opportunities to get confused, etc. I mean, by the same token, just working out this square root through guessing numbers and squaring them and hoping that they're nearby would have taken a lot longer and probably been more error prone as well. So all things considered, I do really like this technique. I think it's worth learning if you consider yourself a top student. And like I mentioned earlier, you want to first start off practicing this with a calculator, get familiar with the big picture of what's going on, and only once you've mastered that should you get into the nitty-gritty computations that you'll actually need to perform on the day under test conditions.